Hi everyone, we're going to solve lesson 6, understand functions that we started today. Remember that I assigned pages 75, 76, 77, so we are going to give it a try. Remember, every time we start the homework with reading. So this is going to be our key for the assignment. Remember that before we start this class, we are supposed to know how can you use an equation to represent a proportional relationship. So study the example below. We're going to read the example below. And the example says, study the example showing how to write equations for proportional relationships. Then solve problems 1 through 8. So in this case, I have example. I'm going to say Kata, I'm going to read it that way, is making pizza dough. For example, for every 4 cups of flour, she needs 2 cups of water. Okay, I'm underlining because that's important information. For every 4 cups of flour, she needs 2 cups of water. Represent this relationship using a table and an equation. So the table represents this way. So flour is F. So for every 4 cups of flour, she needs 2 cups of water. So flour. So I have 2, 3, 4, 5, 6, 7, 8. So I'm just following this one. The table represents this proportional relationship. All of the ratios are equivalent to 4 to 2. For every 4 cups of flour, she needs 2 cups of water. So if we simplify 4 over 2, we get 2 over 1. So in this case, flour, 2 over 1. Then I have 3 over 1.5, 4 over 2, 5 over 2.5, and so on. You can also use an equation. So remember, the ratio of flour to water is 4 to 2 or 2 to 1. So the constant of proportionality is 2 over 1 or just 2. So in this case, you can say the amount of flour, F, is equals to the constant of proportionality 2 times the amount of water, W. So your equation is F equals 2 times W. So let's answer the following questions. For example, what does the constant of proportionality represent in terms of the problem? And in this case, you can say you need 2 cups of flour for every cup of water. That's what it means. That for 2 cups of flour, you need 1 cup of water. That's the constant of proportionality. And we have it here. It's 4 over 2. But we simplify and we get 2 over 1. So for every 2 cups of flour, we put 1 cup of water. Okay, number 2. Use the equation in the example. So this equation here, I'm going to put it here. F equals to 2W. Use the equation in the example to find the number of cups of water you need if you have 12 cups of flour. So what are we going to do? Remember, the equation is F equals to 2W. So we are going to, remember, use the equation on the example to find the number of cups of water you need if you have 12 cups of flour. So we're going to substitute 12 equals to 2W. Remember that W is the amount of water. So let's solve the equation. 2 is multiplying, so we are going to divide both sides of the equation. 2 divided by 2 is 1. So this one becomes 12 divided by 2 is 6 equals to W. That means you need 6 cups of water. That's what it means. So we solved the equation for W, and then we got 6 equals W. That's the amount of water, so 6 cups of water. And then number 3, for a different pizza dough recipe, the equation F equals 2.5W represents the number of cup of flour F that you need for W cup of water, that is the constant of proportionality. Explain what it means in this constant, and then in this context. So in this case, 2.5 is the constant of proportionality, 2.5. Okay, I'm going to put it over there because that's the answer. And then you can explain a little bit and says, for each cup of water, you need 2.5 cups of flour. Okay, so if you have 2.5 is the same as 2.5 over 1, which is the cup of water. So 2.5 divided by 1 is equals to 2.5. So that's what the solution is about. So remember, constant of proportionality is the unit rate in a proportional relationship. That's page 75. So let's do 76. So I have that Basir buys 4 small drinks for $6. Write an equation that represents the cost, C, for D small drinks. So in this case, to write that equation, okay, C is C in this case is cost, D is small drinks. So the equation will be C equals to 1.5 times D. That's your equation, okay? Because he buys 4 small drinks for $6. You need to write an equation to represent the cost C for D small drinks. So it's 1.5. In this case, what we did is divide 6 over 4. We simplify, okay? And it's 3 over 2. And we know that 3 over 2 is 1.5. So in this case, number 5, a horse run 800 meters in 40 seconds, 1,200 meters in 60 seconds, and 480 meters in 24 seconds. Is this a proportional relationship? If so, what is the constant of proportionality? Remember, this is a review from last year. What does it represent? Write equation to represent the distance D in meters that the horse runs in T seconds. So in this case, you can type, look at this one. A horse ran 800 meters in 40 seconds, 1,200 in 60 seconds. So you have 800 meters in 40 seconds is equals to 20. So if you do 800 in 40 seconds is equals to 20. If you do 1,200 meters in 60 seconds is equals to 20. That is your constant of proportionality. So in this case, you're going to answer. If so, what is the constant of proportionality? Is this a proportional relationship? Yes. Yes, it is. And in this case, the constant of proportionality is 20 over 1. Okay, we always have that 1 in the denominator, which means that the horse can run 20 meters in 1 second. Okay, the equation in this case, it says meter that horse in T seconds. Write an equation. So the equation will be that the distance is equals to 20 times T. Okay, so that's the represent of the situation. Number 6, the equation C equals to C points for The equation C equals 6.4W represents the cost C for W pounds of walnuts. Does the value of 2.5 for W make sense in this situation? Explain your reasoning. This problem number 6 is a medium problem. It's not that hard. So in this case, we're going to type, does this make sense? And in this case is yes. It does make sense because you can buy £2.5 of walnuts. Okay, remember, read the problem. The equation C equals 6.4W represents the cost C for W pounds of walnuts. Does a value of 2.5 for W make sense in this situation? Remember that W represents pounds. And it makes sense, 2.5, because you can go to the supermarket and buy 2.5 pounds of walnuts. It's just a bag. If you go to Martin's, you can get 2.5 pounds. They usually have these big containers of walnuts, so you can buy. Number 7. Number 7 in this case is a little bit more challenging problem, as you can see. Lina and Michelle studied the data in the table. They each wrote an equation to represent the relationship between the number of miles and the number of hours ridden by a bicyclist. Lina's equation, m equals to 9 times h. Michelle's equation is h equals to 1 over 9m. The teacher said that both equations were correct. Explain why. Remember, we have a table, miles and hours. So in 27 miles, they spend 3 hours. In 45 miles, 5, and so on. Okay? So in this case, you can have as possible an explanation that Lina's equation shows that the bicyclist rides 9 miles in 1 hour. Michelle's equation in this case shows that the bicyclist can ride 1 mile in 1 over 9 of an hour. Okay, so they did the opposite of the equation. So in this case, the equations are 2 different ways of expressing the same relationship. Okay, so it's just exactly the same. For example, look at this one here. M equals 9 times h. Okay, so miles is equals to 9 times the amount of time. What is 3 times 9 is 27. So that's the relationship. So what they did is divide both sides by 9 and you get 1 over 9m equals to h. So we are going now 27 divided by 9 is equals to 3. So they did the opposite situation. And then number 8 is a medium problem. You have that Zach's car travels 21 miles in 1 gallon of gas. Write an equation to represent the relationship between the gas Zach's car uses and the distance he travels. Then solve the equation to see how far Zach traveled on a trip if he uses 16 gallons of gas. So the equation in this case is distance okay, is equals to 21 over G. 21 times G, which is 21 times the gallons of gas. So in this case, what we're going to do is D equals to 21 times 16, which is equals to 336 miles. So we just substitute the 16 gallons for G, which means gallons. So in this case, Zach travels 336 miles if he uses 16 gallons of gas. Okay, that's page 76. Now let's do page 77. Now we are identifying functions in lesson 6. This is the key. Study the example problem showing how to determine whether the relationship is a function, then solve problems 1 through 7. We're going to do only 1 through 3, and then we're going to assign the rest next class. So you have described a relationship shown in each table. Is the relationship a function? Remember that I mentioned in class that relationship is a function if the input values do not repeat. So let's look at this input. 1, 2, 3, 4, 5. The input is not repeating, so this relationship is a function. The input identifies the hours and the output gives the cost of those hours. The relationship is a function because there is only one output for each input. Let's say it. The input do not repeat. The input identifies the week and the output gives the growth of each week. The relationship in this case is a function because there is only one output for each input. So 1, 2, 3, 4, 5. There is no repetition in the input, so there is a function here. 1, 2, 3, 4, 5. Now, let's answer the following questions. Question number 1. Can you represent either of the function in the example problem with an equation? Explain. So in this case is in table A, you can, okay, let me type this one. In table, the function in table A can be represented by C equals to 3H, okay? C equals 3H, where this case C is equals to the cost and H equals hours. Okay, thus can you represent either of the functions in example problem with an equation? Explain. So in this case I choose table A. See, 1, 3, 2, 6, 3, 9. So if you divide 15 divided by 5, 3, 6 divided by 2, 3, 9 divided by 3, 3, 12 divided by 4, 3, and so on. So in this case, your equation is cost equals 3 times the hours. Number 2. Suppose you reverse the input and outputs in table B. Will the relationship be a function? Explain. So table B. Now, these are not my inputs. My inputs are now these numbers. So I have 4, 3.25, 2, and 2, and 1.75. I have repetition. These two numbers repeat. So the reverse of that table is not a function. Is not a function. So in this case, the answer is no. Okay? It will not be a function. There will be two different outputs for the input 2. So as you can see, this input 2 have different numbers. You have the repetition, so it's not a function. Number 3, the table shows the number of concert tickets sold by 5 students. Is the relationship a function? Explain. I have the input 1, 2, 3, 4, 5. Is the repetition? No. So yes, it is a function. Yes. Now, what is the other question? Explain. There is only one output for each input. Okay, so remember that function, a rule that produces exactly one output for each input. I have the following problems. I'm going to leave those ones for next homework. If you have any question, please, email me, and I will be able to, I would love to help. So you have a wonderful day.